Good morning everyone. My name is Sudheer Kumar, working as an assistant professor of mathematics in MLR Institute of Technology. Last class we have seen the Laplace transforms basic definition, few applications and problems on some elementary functions. This lecture I am going to give lecture on first shifting theorem in Laplace transforms. First shifting theorem and Laplace transforms, problems on it, and in this lecture we are going to cover unit step function and change of scale property. First of all, let us see first shifting theorem statement. If Laplace transform of f of t is equal to f bar of s, this is basic definition of Laplace transform. Now we are going to find Laplace transform of e power at, Laplace transform of e power at into some multiplication f of t. We are multiplying the function f of t with e power at, and the result is f bar of s minus a. This is f bar of s minus a, and few applications of this first shifting theorem. Let us see. Laplace transform of e power at into t power n. This is n factorial by s minus a whole power n plus 1. So first let us, if you want to find Laplace transform of e power at into t power n. So other than e power at, first consider this function t power n. What is Laplace transform of t power n? That is n factorial by s power n plus 1. This is Laplace of t power n. Now I want Laplace of e power at into f of t. So when we are applying first shifting theorem, here we have e power at, so replace s with s minus a. So we get n factorial by s minus a whole power n plus 1. Similarly, if I want to find Laplace transform of e power at into sin bt. So other than e power at, first consider sin bt. You know what is Laplace transform of sin bt? That is Laplace transform of sin bt, that is b by s square plus b square. This is Laplace of sin bt. Now I want Laplace of e power at into sin bt. So whatever function you get in this, just replace s with s minus a, because we have s e power at here. Suppose if we have e power minus at, just replace s with s plus a. Right. So when you replace s tends s minus a, we get b by s minus a whole square plus b square. Similarly, Laplace of e power at into cos bt. First find the Laplace of cos bt, that is s by s square plus b square, isn't it? After finding Laplace of cos bt, when we are applying first shifting theorem, s tends to s minus a, just replace s with s minus a. So we get s minus a by s minus a whole square plus b square. Just wherever s is there, in place of s, replace with s minus a. Right. Now let us see problems on it. Laplace transform of e power minus t cos 2t. First find Laplace transform of cos 2t. This other than e power at, first find Laplace of this function. What is Laplace of cos 2t? S by s square plus 2 square, that is s by s square plus 4. So L of Laplace of f of t is some function of s. Let us assume this function as f bar of s. Now I want Laplace transform of e power minus t into cos 2t. So whatever function you get f bar of s, as per the first shifting theorem, what can we say? This can be written as f bar of s plus a. This is f bar of s. In place of s, just you are replacing with s plus a. Here a means what? E power minus at, a means 1. So s upon s square plus 4, just replace s with s plus 1, because e power at, a is minus 1. So, in place of s just we write s plus 1. So, this gives s plus 1 upon s plus 1 whole square plus 4. If you want to expand further, you can expand this. This can be written as s plus 1 upon s square plus 2s plus 5. This is the answer, right. Now, let us see one more problem on it. Find Laplace transform of e power minus 3t into 2 cos phi t minus 3 sin phi t. So, other than e power a t, first consider this as f of t. So, let f of t is equal to 2 cos phi t minus 3 sin phi t, right. Now, let us find Laplace of f of t, that is f bar of s. What is Laplace of f of t? That is Laplace of 2 cos phi t minus 3 sin phi t. So, as per the linear property, we can split this Laplace transform. This can be written as Laplace of 2 cos phi t minus Laplace of 3 sin phi t. As per the linear property, we are writing this by linear property, right. Since 2 is constant, let us take it outside. 2 into what is Laplace transform of cos phi t? That is s by s square plus a square. Here a means what? 5. So, 25, 5 square minus, here 3 is constant, let us take it outside. What is Laplace transform of sin phi t? A by s square plus a square. Here a means what? 5. 5 by s square plus 5 square. So, this is 2s by s square plus 25 minus 3 is a 15 by s square plus 25. This is Laplace of f of t. So, I am considering this as f bar of s, right. Now, let us find Laplace transform of e power minus 3t multiplied with f of t. By first shifting theorem, whatever s is there, you replace s with f bar of s plus a. A means what here? 3. So, just replace s with s plus 3. So, this can be written as 2 times of s plus 3 upon s plus 3 whole square plus 25 minus 15 upon s plus 3 whole square plus 25. Just in place of s, we are replacing with s plus 3, because a is equal to minus 3. This is by first shifting theorem. By first shifting theorem. Still, if you want further, you can simplify this. This can be written as 2s plus 6 minus 15 divided by s plus 3 whole square plus 25, because denominator is same for both the terms. So, s plus 3 whole square plus 25, this is 2s minus 9. Still, if you want to simplify further, you can write down one more step, 2s minus 9 by s square plus 6s plus 9 plus 25, 34, right. Let us see one more problem. Find Laplace transform of e power minus t into cos square t. So, what is f of t here? Other than e power minus a t, let us take function as f of t. So, let us take f of t function as cos square t. We do not have any direct formula to find Laplace of cos square t. We have Laplace of sin t, Laplace of cos t, but we do not have direct formula for cos square t. So, what we will do is, this can be written as 1 plus cos 2t by 2. Just we are replacing the function cos square t with 1 plus cos 2t by 2. Now, Laplace of f of t, that is Laplace of 1 plus cos 2t by 2. This 1 by 2 I can write it outside. Using linear property we can write this as Laplace of 1 plus Laplace of cos 2t. This is by linear property. We know that this Laplace of 1 can be written as 1 upon s plus Laplace of cos 2t s by s square plus a square. Here a means what? 2. So, 2 square. So, this is 1 by 2 into 1 upon s plus s by s square plus 4. Now, let us assume that this function as f bar of s. We want Laplace of e power minus at into f of t. So, Laplace of e power minus t into f of t is equal to, by first shifting theorem what can we say? This is f bar of s plus a. Here a means what? This is f bar of s. I want f bar of s plus 1. Just in place of s replace with s plus 1. So, this can be written as 1 upon s plus 1 plus s plus 1 by s plus 1 whole square plus 4. Further we can simplify this. So, this can be written as 1 upon 2 1 by s plus 1 plus s plus 1 by s square plus 2s plus 5. Still if you want to further simplify you can simplify, otherwise you can leave it up to here, right. Now, let us see, find the Laplace transform of e power 3t into sin square t. Other than e power a t, whatever function is there, let us assume it as f of t. So, what can we assume here? F of t is equal to sin square t. For this function let us find Laplace, then apply first shifting theorem. So, Laplace of f of t is equal to Laplace of sin square t. What is Laplace of sin square t? We do not have any direct formula. So, sin square t can be written as 1 minus cos 2t upon 2. So, this 1 by 2 I am writing outside. Laplace transform of 1 minus Laplace transform of cos 2t. So, 1 by 2, what is Laplace transform of 1? Laplace transform of k is k by s, Laplace of 1 is 1 by s. Laplace of cos at, s by s square plus a square, here a means 2. So, s by s square plus 2 square, that is 4. Now, I am assuming this function as f bar of s. I want Laplace of e power 3t into f of t. Therefore, Laplace transform of e power 3t multiplied with sin square t. By first shifting theorem what can we say? This is equal to f bar of s minus a means what? 3. So, in the function f bar of s replace s with s minus 3. So, this can be written as 1 upon s minus 3 minus s minus 3 by s minus 3 whole square plus 4. And further if you want to take out LCM and further we can simplify this. These are all about first shifting theorem. Now, let us see problems on this. Laplace of e power 4t sin 2t cos t. So, here f of t is sin 2t cos t. We cannot find Laplace of f of t as Laplace of sin 2t into Laplace of cos t. We can't write like this. So, to find the Laplace transform of f of t, Laplace transform of f of t means sin 2t cos t. So, I am just multiplying and dividing with 2. Laplace of 1 by 2 into 2 sin 2t into cos t. This 1 by 2 I am writing outside. This is in the form of 2 sin a cos b. 2 sin a cos b can be written as sin of a plus b plus sine of a minus b. Here a means 2t and b means t, just replace in this formula. So, this can be written as sine of 2t plus 3t, 2t plus t is 3t plus sine of a minus b, sine of 2t minus t is t. Now, we can apply linear property and apply Laplace transform. This is Laplace transform of this. So, 1 by 2 into Laplace of sine 3t is 3 by s square plus 9. What is Laplace transform of sine t? A by, a means 1 by s square plus 1. This is f bar of s. Now, I want Laplace transform of e power 4t into f of t. Therefore, Laplace transform of e power 4t into f of t. By first shifting theorem, this can be written as f bar of s minus a. Here a means 4. Just in place of s, write down s minus 4. So, this can be written as 3 by s minus 4 whole square plus 9 plus 1 by s minus 4 whole square plus 1, right. Now, let us see unit step function, which is also called as Heaviside unit function. Unit step function is denoted with u of t minus a, or also we can represent it with h of t minus a, and it is defined as this function is equal to 1 whenever t greater than a, and the function is equal to 0 whenever t less than a, where a is always greater than or equal to 0. For this unit step function, let us apply Laplace transform. So, Laplace of u of t minus a, as per the definition, what is Laplace of f of t? Definition of Laplace transform, integral 0 to infinity e power minus st into f of t dt. Here the function is unit step function. The formula is e power minus as by s, where s is greater than 0. Laplace transform of unit step function is e power minus as by s. Now, let us see change of scale property. We know that Laplace of f of t is equal to f bar of s. Now, I want to find Laplace of f of a t, and the formula is 1 by a into f bar of s minus a. Using this change of scale property, let us find a Laplace transform of this function. E power minus 3t sin h 3t. This is in the form of sin h a t. You just compare this. Here a means 3. So, first let us find Laplace transform of sin h t, because this is h a t means f of a t. First I want what is f of t. This can be written as sin h t. So, sin h t is f of t. What is Laplace of sin h t? Laplace of f of t, that is 1 by s square minus 1. This is f bar of s. Now, apply change of scale property. What is change of scale property? 1 by a into f bar of s by a. When you know f bar of s, we can write it f bar of s by a easily, just replacing s with s by a. Here a means what? 3. So, this can be written as 1 by 3 into f bar of s by 3. So, in this function, just replace s with s by 3. So, this can be written as 1 by 3 into 1 by s by 3 whole square minus 1. This can be written as 3 by s plus 3 whole square minus 9. How you are writing this? By first shifting theorem. S is shifting from s to s plus 3. So, this can be written as 3 upon s square plus 6s. So, this lecture today we have covered first shifting theorem and problems on it, unit step function and change of scale property. Next lecture we are going to cover second shifting theorem and problems on it, and multiplication by t power n. What is Laplace transform of t power n, and we will be seeing problems on it. Thank you.